Alright, hello everyone. So let's continue our lesson. Now, we learn about system of differential equations, how they look like. Basically, they are a collection of differential equations, right? But they are working together, right? You cannot isolate them. The thing about this chapter is then we have to go back to chapter 1 and chapter 4 and visit again concept like linearity, homogeneity, fundamental set of solutions, and we have to restate them in the eyes of system of differential equations. Okay, so we have to restate all of those concepts in terms of systems, but you already know those concepts, so it's going to be an easy task. Okay, all right. So now here we have a system of differential equation. Now in this course we are only going to learn about linear system of differential equations, just like we learn about linear high order differential equations in chapter 4. So we are restricted to linear differential equations. So what is it? What does it mean by a linear system? Well, guess what? Try to think. Try to develop an analog between linear differential equations and a linear system. Well, a system of differential equation means basically a collection of differential equations, right? That means you have 3, 4 or 2 differential equations. So in order for this system to be linear, that means each of these differential equation has to be linear, right? That's the idea. So look at this differential equation. Everyone needs to be linear if you want it to be a linear system. But if you have at least one differential equation in the system that is not linear, that is non-linear, then the whole system is non-linear. So what do you want it to be linear? Well, here on the left hand side we have dx1 over dt, dx2 over dt. Well, x1, x2, all of them are dependent variables, so their powers should be 1, right? Remember, so there should be of power 1. That is needed for linear differential equations, right? So as you can see, the powers are 1. Then the coefficients, they have to be functions of only independent variable. Look at these terms that are marked in A. They are only defined to be functions of t, right? Because inside the parentheses you can only see t. T is the independent variable. Well, that's it. Then you are linear, right? And then the non-coefficient function, which are like these f terms, okay, they do not have a dependent variable associated to it, so they are non-coefficient functions. Like an isolated function, they also need to be functions of only independent variable, right? Which is the case here. Independent variable is t. That's what we have. So this is a linear system. This is how a linear system look like. All right. Then we have to discuss about homogeneous system. Guess what is homogeneous system? Homogeneous system means all the differential equation in your system have to be homogeneous. That means your non-coefficient function should be 0. That means you should not have these f terms. They should be 0. Here actually this is a non-homogeneous system because of course you can see this functions f. Okay. All right. Now that's not the most important thing. What we are going to do is, when you have a system of differential equation, we are going to write it in matrix form. Now what is matrix form? Pay attention what I'm going to do here. I'm going to define a vector capital X, okay, uppercase X, and in this vector the elements are all the dependent variables. So let's say x sub 1, x sub 2, x sub 3, blah blah blah, x sub n. So I have a vector. In this vector you have all the dependent variables in the order, okay? All right. Now let's look at the left hand side of this system of differential equation. If you look closely, each row, okay, so we have rows, right? Row 1, row 2, row 3, blah blah blah, and row n. Right? Each row contains the first derivative of that independent variable, right? Okay, so we can write, we have a vector with dependent variables, so we can write x prime where each row of this vector are the derivative of each dependent variable. So x1 prime, x2 prime, blah blah blah, xn prime. So what is x1 prime? X1 prime, for instance, means dx over dt. Okay, x2 prime means dx1 over dt. x2 prime means dx2 over dt, right? Okay, so the left hand side of this system of differential equation, then I can write as x prime, capital X prime. So it's like a short form. Okay, so if you look at this system of differential equation, it's huge. Okay, you have to write several lines. Now I'm trying to avoid it. I'm trying to give a general representation. So the left hand side in one shot I can write as x prime. Okay, now look at the right hand side. Now I'm going to focus only on, let's choose a different color, this part. Forget about these f terms. Okay, all right, now look at the first row. A11, A12, A1n, A21, A22, A2n. Okay, and they are all multiplied by the each dependent variable. Here's what I'm going to do. What I'm going to do is I'm going to write a matrix here. In the first column, in the first row actually, I'm going to take all the coefficients in the first row and put them in the first row. So here A11, A12, blah blah blah, A1n. And I'm going to take each coefficient in the second row and I'm going to put them in the second row. A21, A22, A2n, and I'm going to do that for each differential equation. So the last row is an1, an2, and ann. So what I basically did is I extracted all the coefficient of the dependent variables and throw them in a matrix, but in order. Okay, all right, and then this is multiplied by the vector x. Now what is vector x? x1, x2, x3, all the dependent variable. Okay, so what's going on here? Now think about this. Multiply this matrix and vector. Hopefully you know how to multiply a matrix and a vector. If you multiply the first row by this vector, see what happens. A11 x1, A12 x2 plus A13 x3. That is exactly what you have here on the first row, right? Okay, so when you multiply this matrix and this vector, you get back this part of the system of differential equation. All right, then what can we do about these f terms? Well, I can write them as plus f1t, f2t, function of time, f3t, and blah blah blah, fnt. So I can write this as basically the system of differential equation as x prime. Let's call this coefficient matrix as A, capital A. This is capital X, plus let's call this vector as f. This is how you represent a non-homogeneous system of differential equation. X prime is equal to ax plus f. F is the non-homogeneity vector, okay, that contains all the information about non-homogeneity. A is the coefficients of the dependent variables on the right hand side. X is the dependent variable vector. Now this might be a little bit confusing. Let's do some examples. But before going to there, then how about a homogeneous differential equation? System of differential equation. What does that look like? X prime is equal to ax, because f is 0, right? Because that's the non-homogeneity part. So this is how a homogeneous system will look like. All right, enough of that. Let's look at examples. Here, how can we write this two differential equation system as in matrix form? Well, x prime, that's always fixed. Now extract the coefficients in order. Coefficients of the first row, 2, -4. Coefficient of the second row, 1, 5. And what is capital X? Well, capital X is the dependent variables in order. So here x and y are the dependent variable. So this is how you write the system of differential equation converted into matrix form, where we can work with linear algebra from there. That's the idea. Okay, all right, so let me show you more examples, because I have to show you a non-homogeneous example. Well, this is also homogeneous. X prime is equal to, extract the coefficients. So first row, -1, 4, -2. Second row, 3, -2. Coefficient of z is 0, so 0, because there's no c here. Here 1, 3, -2. Take them in order, okay, be careful. So this is x, y, z vector, right? This is the dependent variable vector. Super easy, right? Simple enough. All right. How about this one? Well, now we have a non-homogeneity because these t terms, they are not dependent variables, so they are the non-homogeneous part. So let's write this. X prime is equal to, extract the coefficient, -1, 4, -2. Let's write them first. Forget about t's, okay? Let them be there. 3, -2, 3. Oops, not 3. Don't do that mistake. This 3 belongs to t, not to z. So 0 here. 1, 3, -2. Now this is x, capital X, which is xyz vector, plus the non-homogeneity now. T, 3t on the second row, -5t on the third row. Okay, remember I took it with the sign. Okay, it's -5t, so I had -5t here. So this is x prime ax plus f. What is a? This is a. What is capital F? This is capital F. Let's see, do I have another example? That's all. Okay, all right. So that is how you write. That is exactly how you write a given system of differential equation into matrix form. So from there we can use linear algebra, but that's a discussion for later. But that is how you write matrix form. Okay, all right. Thank you very much. Bye bye.